The type of integral that you see here is called an indefinite integral, and definite integrals have a number for a superscript and a subscript here that would ask you to integrate this over a certain x interval. So when you're asked to integrate f of x, what you get is what's called an antiderivative. What we have here is a definite integral, and it's asking you to integrate this between a and b. So this is going to be f of b minus f of a. So if we're going to integrate 5x to the fourth dx from 1 to 4, what I want to find is the antiderivative at 4 minus the antiderivative at 1. What this is going to give us is a section under the curve here where we can get the area of this space in here. So this would be our b minus this number, which is our a. So first we integrate 5x to the fourth. We start with our x, we increase the exponent by 1, and we divide by this n plus 1, and we had a 5 to begin. These will simplify to be a 1. So this is just x to the fifth plus c. Now, it doesn't matter what the plus c is because it will have no bearing on what's going to be the area under this curve. So now as we see up here, we want to see f of b. So I'm going to replace the x value with a 4. So this will become 4 to the fifth minus, and then this one over here would be at a, is 1 to the fifth. So 4 to the fifth is 1024. And 1 to the fifth is 1. And then when we subtract, we get 1023 as our answer. This time we're being asked to integrate x to the third plus 1 from 0 to 2. So to integrate this, I increase the exponent by 1, I divide by that, plus, and the integral of 1 is just going to be x. There is a plus c. At the conclusion of this problem, I'll show you why the plus c doesn't make a difference. Next, I want to substitute for x. We're going to put in the b value, so the x would become the b value, so this is 2 to the fourth power. And the x would also become a 2. And 2 to the fourth is 16. 16 divided by 4 is 4. And finally, 4 plus 2 is 6. And for the second part of this, we're going to subtract f of a, and this time a is going to be 0. Well, if I put 0 in here, I would have 0 over 4th plus 0, so this is just going to be 6 minus 0. So the final answer is a 6. To show why a constant doesn't affect the outcome of a definite integral, let's do this problem over here. So I start with x, I increase the power by 1, and then I divide by the new n plus 1. So 2 divided by 2 gives me 1. So I just get x squared plus c. Now, without doing the substitution, let's say that this part is f of b, and I have to subtract now f of 1. So when I have x squared plus c for f of 1, that when I have the c minus c, they're going to add up to 0. So the only thing that's going to matter are the x terms once I substitute in my a and b here. There are some rules at play when you're working with definite integrals. Let's take a look at some of them. So for the first rule, if we have a definite integral from a to b and I switch the a to b b to a, then this will be equal to the negative of the original integral. Now, if we have a definite integral and we're going from a to a, then on a graph, this is just going to be a single line on the graph straight up and down, and there won't be any area under the curve. And as a result, this would be equal to 0. For this property, it's saying that if I find the integral from a to b of some function f of x dx, that would be the area under this part over here. And then I find the definite integral of f of x dx from b to c, that would be finding the area under here. That if I was to add these two integrals together, they would be the same as the integral of that function from a to c, which is the area of both of them put together. If we are asked to find the integral of f of x plus g of x dx from a to b, that is the same as the sum of the individual definite integrals. And the same works when we are subtracting the two functions up here. This would become a minus sign again. So the definite integral of f of x minus g of x dx is the same as the definite integral of f of x dx minus the definite integral of g of x dx. Lastly, if the definite integral is above the x-axis, then the integral is a positive one. And if the integral from a to b is below the x-axis, then it is negative. If the integral is half above and half below, where this is positive and this is negative, it is the sum of their areas. So let's look at this definite integral and its resulting graph. To integrate 2x, I start with x, I raise the power by 1, divide by that new power, and divide the 2's through, and what I get is just x squared. So now what I want to do is I want to evaluate x squared first at 3, so this would be 3 squared minus, and then I would do x squared at 1, which is 1 squared. So 3 squared is 9 minus 1. My answer is 8. So here we have the graph of x squared. And what this problem is telling us is that the area between a and b, which is 1 and 3, this area that's inside here is equal to 8. So here we're given the definite integral for x to the fourth plus 3x squared plus 3x divided by x from 1 to 3. First thing I want to do is simplify this so that it's no longer a fraction. So what I get is x to the third plus 3x plus 3 from 1 to 3. Now I'm able to integrate. So I start with x, increase the power by 1, and divide by the new power. Plus, same thing here. I'm going to bring down the 3. So I increase the power by 1 and divide by that power. And over here, I just add the x in front of the 3. Now what you do is you substitute in 3 in each of these terms. 3 to the fourth power is 81 over 4, plus 3 squared is 9, times 3 is 27 over 2, and 3 times 3 is 9. 81 divided by 4 is 20.25. 27 divided by 2 is 13.5. And adding all of this together, I get 42.75. Now we'll go back and we'll evaluate this at 1 and subtract it from here. 1 to the fourth power is 1, so this is 1/4, so this is 0.25. Plus 1 squared is 1, 3 times 1 is 3, 3 over 2 is 1.5. And finally, 3 times 1 is 3. Adding all this together gives me 4.75. And when I subtract this, I get 38 as an answer.